I want us to look now at how to find the area of what we're going to call a complex shape. And the reason we call this a complex shape is because this isn't simply a square or a rectangle or a triangle, but it's a shape that's actually more than one shape put together. And so we've already talked about that for a rectangle or a square we can just multiply the length and the width. But this time we can't just do length times width. It has more than one length and more than one width on the figure. And so we're actually going to do three different ways of how to solve this problem. The first way we could do it is we could actually divide this into two shapes. We could actually say that this is a rectangle, and then we could say that this is a square. And if we do that, we know how to find the area of a rectangle and a square. This rectangle, first we'd actually need to know that if this distance is 2 and this distance is 2, then this side over here is actually 4 centimeters. So to find the area of the rectangle, we just multiply the length and the width, and we recognize that this rectangle has an area of 32 square centimeters. There's 32 squares that could fit in there if the squares were a centimeter each. And then we look over here and we have a square in the smaller shape, and its length and width are both 2, and so we would do 2 times 2, and we'd find that it has an area of 4 square centimeters. And then if I wanted to know the total, well, if I've got 32 squares in the rectangle and 4 in the square, if I added them together, it would give me the total number of squares. The entire figure is 36 square centimeters. And that's one way to do it. On a lot of problems, if we actually take a complex shape and we can make it into rectangles and squares, then that's a lot of times the easiest way to do the problem. But it's not the only way. The other way some of you may have thought to do this problem would have been to make this into two rectangles like this. We wouldn't even have to figure out that the other side was 4, but you could say there's a rectangle up top. It has a length and width of 8 and 2, so when you multiply them together, you would say that this is 16 square centimeters. And then we would look, and then there's another rectangle at the bottom. And the rectangle at the bottom is also too tall, but we'd actually recognize that it is 8 and then 2 more, and so it is 10 centimeters at its base. And so its side lengths are 10 and 2, and we would do 10 times 2, which would be 20 square centimeters. And if we added those together, 20 and 16, we would get 36 square centimeters, which is, we can see that they're both right because that's the exact same answer we got before. This is still the same figure, and it's still 36 square centimeters. There's actually another way we can do it that's not deconstructing, but it's actually going to add to the rectangle. So let's take a look at that next. Okay, my final way of doing it, it's not how I would do this problem, because this is a fairly simple problem, but as the problems get more complex, it's really useful to know is that instead of looking at this as more than one rectangle, we could look at this as being part of a larger rectangle. So let me draw my large blue rectangle here. Within this blue rectangle, it's almost like there's a bite removed from this rectangle. And so the first thing we could do is we could find the area of the larger rectangle. And if we recognize that if the length is 10 right here, and that this is 2, then we actually know that this has a side length of 10 centimeters. And then the height, we have 2 is this distance and 2 is this distance, so it's 4 centimeters. And so my large blue rectangle has an area, when you do 4 times 10, of 40 square centimeters. But I don't want to know the area of the whole thing. I only wanted the area of the original figure. And so this part that I'm putting in pink here, this is actually not what we're finding the area of. So what we'll do is we'll actually find the area of this square, and we recognize that it's 2 by 2, and so it is 4 square centimeters. If I had 40 squares and I remove 4 of those squares, then the remaining part is 36 square centimeters.